get the answer? Yeah. Yeah. Boleh. Same. Same. Same, huh? You saying congratulations. If not same, then you have to try again. Okay. So, look at the question, huh? So from A generate preferences, B and C, right? Generate B and C. So this is another level. So always start from the left hand side, generate from B. B can go to donkey and F. Donkey and F. Okay, no more. So, okay, so horizontal, D and F. So C give you what? C give you E and F. So F already here, right? So we just put a dotted line. Okay, if you don't put, it's okay also. So we have an E and F here. No more solutions. Next, donkey. Expand from donkey, you will get G. Okay, so that is your resulting tree. Okay, so how the professor do the search, right? Search like this. So what is the return path? A, B, D, G. So this is the return path. What is the search path? A, B, C, D, F, E, and G. How the algorithm do the search from this way. So that versus very simple. A expand to B, B can expand to D, D can expand to G. Now this is your solution. Stop it here. So that is your resulting tree. So what is the return path? A, B, D, G. What is the search path? A, B, D, G also. Okay. So if you compare both completeness, yes, both give you the solution. A to G, yes, both yes. Is it optimal? Preferences guarantee yes. So preferences take how many stations? 1, 2, 3, 4. 4 stations. Preferences 1, 2, 3, 4. Also 4 stations. So both also give you optimal solutions. If you look at the third one about time efficiency, time efficiency, whether is it time consumption and time efficiency is two different things. Time consumption is high or low. Time efficiency is it take faster to reach the solution or lower, right? So in this case, preferences definitely take lower because you go straight away 4 stations. This one you have to go from here. So the time efficiency for this case is very low. Okay. Meanwhile, for the space consumption for this case is definitely low or more because you need more memory to store all the nodes. But for preferences, there's only 4 nodes. Only 4 nodes. You just need to store 4 nodes compared to the preferences. Okay. Good. So how about this? Another question. This is midterm test. You probably won't get it from the intranet. So this is a partial question. So the question 1. Russia always propose 4 different types of AI. So this one I think you should know This one is in the tutorial. So we have a act like a human, act rationally, think rationally, and think like a human So question 2 is about blind search, differences and preferences also. I think this one is more complicated compared to this question. Yeah, you can try this, and then after that shows the return path as well as the resulting tree. Okay, but sometimes the question may ask show the search path. So this one is return path. Sometimes you are required to show the search path also. And then compare the performance in terms of only completeness and the optimality. Okay, so I'll give you another maybe 10 minutes 10 minutes. chapters. So I want you to try it first. So next week only I will show you our answer. Okay? So you go back and try first. Boleh? Okay. Alright, so that's it for today's chapter 2, but chapter 3. So but before we end this class, I would like to show you some AI related projects that give you some ideas on like how you to give you some ideas on your maybe assignment or maybe for your F5P projects. So some of the projects here are actually from my F5P students. Some of them are actually from the assignment. Mainly I extract from image processing because there's something to show you. For like recommended system or chatbot, I don't think I have that video. I forgot it. I extract from during the MCO. There were live presentations, so I will just extract some of the project from it. Okay, so the first one is using a deep learning or machine learning to predict the stock trade or the price. So these are actually a F5P project done by these students. So you can actually scan this the QR code, so it will lead you to the platform. You can just key in the so-called the stock name, and then behind, so we will use the LSTM as well as there's one more algorithm, but I cannot remember the names. So they will train the historical data of the data set, and then to predict the stock price. So you can scan and then you can put it out, but it will take a lot of time because it involves a very so-called deep learning. So you will see that it takes a lot of time to produce you the result, and as well as the hardware problem. So okay, so this is the first example. So the next example will be the so-called Eczema Tracker. So what is Eczema Tracker? It's actually a mobile app. So they integrate this AI module into the very simple apps application here. So the purpose of this object is to identify the eczema level. So what is eczema? It's actually a skin disease. So there are several levels on the skin disease. So this company called Lipid Group, they approach us and so-called collaborate with us. So their requirement is to build the apps for the user use so that they can scan their skin conditions, and at the same time we will provide the user their eczema level, whether is it in the level 2, whether it's in the level 3. So beside that, so we need to provide them also during, for example, week 2, what food they actually consume here, and also week 3, so that we can do a comparison, right? If let's say in this case January, so we see that from the week 2, the eczema level is in the level 4, it somehow dropped to the level 2 in the week 3. Then based on here, we can actually see the summary, right? What are the food that actually you consume, or maybe other environments where you can avoid or maybe reduce the eczema level. So you can also scan this QR code and get the apps. You can actually install the apps and sign up as a user. And then inside this app also there are some other features. For example, you can purchase the product from this company. So this company actually provide the solutions for the eczema. So it's actually done by quite many students. So we spent quite long, I think 2 years to complete this. So this is also another project where the students find out that some of the Chinese herbs are actually look like similar. So they build a simple apps, use a deep learning, again train the models to identify or to classify these 3 different the Chinese herbs. So you can also scan the QR code, so it will lead you to the drive. You can install the apps and play around with it, but it can only classify 3 different herbs. So if you need to more detections, then you need probably put in more images. So we have wall crack detection here. So I don't think this link is workable. I think the link is not working anymore. So what is this? Is actually to build the application to detect the wall cracks. So why do we need to detect the wall cracks? It's because we found that quite many buildings, high-rise buildings, for example, the condo, if there's any damage there, we cannot detect. So we use the drone to actually capture the image surrounding the buildings. Okay, and then this image will send to this so-called neural networks and to identify the wall cracks. So then we will have a dashboard to identify which area, which region we have a crack, what is the crack width, all the informations. Then we will take action, maybe go and repair the buildings or the wall. This is I think this is an assignment. Yeah, this is one of the assignments. So students build the apps to identify different fruits using different algorithms. They have actually done a very good job. Only 2 months or 2-3 months they built these apps. You can see that there are 3 different algorithms to identify the orange and then the so-called melons. The melon. Melons. Let me show you the confidence level. So it show you what melon 100%. So this is another models. Okay, so another algorithm shows that this is a melon, only 81% of confidence levels. Orange is 30%. So this one show cucumber. So this is not true lah. But they did mention what is the reason why the confidence level for this is very low, because they are using image on the internet, not the real image. So probably that will be the root cause, the reason why. So we have face recognition, project, real time, or also using the images. Besides detect the face, it also identify who is this person and as well as the genders. So this is a real-time face recognition. It's quite smooth, so you will see that the name is down here as well as the genders. This is sentiment analysis. It's not related to image anymore, but they would like to study the sentiment of the comment after that someone bought the products or the items from the Amazon. So they leave a comment. So we would like to know the comment whether is it a positive or negative, whether this product is good or not. So we can actually crawl the data from the Amazon, the reviews, and then perform some machine learning, identify whether this is a positive review or a negative review. So and then this project is actually divided into three different modules. Crawl the data, perform some pre-processing, and then the last one is to perform the machine learning. So it's actually performed by these 3 different students. So the first one you can see that just now we have how to crawl the data, and then the second one will be the image the pre-processing stage here. So we have a raw data from the internet. We have to perform the data pre-processing on the text, and then lastly we have a last student to perform the machine learning. Okay, so we use a different algorithm, for example, the 9 bias and what else? Support vector machine, and to perform the calculate, and then eventually you will see that the comment, right? This is actually the comment. So what is the whether it's a positive comment or negative comment? So it will show here it's a positive comment, and then these are the negative comments. So what is the polarity? What is the value? The intensity of the positive or negative reviews. And then the last one will be the this one. Sorry, I didn't change the name. So by right, this is the hand signature detection. So this is actually to use the skeletons library to identify the fingers. Okay, in the night mode as well as the day mode. So this is in the day mode. So later on it will show the night mode. So yeah, you can even identify the fingers at the night mode. So meanwhile, the second student, she use the same things, use the same libraries, but give some command to this skeleton. So like for example, this is hello, this is okay, and yeah. So using a MediaPack library, so even identify the fingers, how many fingers are there. And then the last one will be the hand controller to control the website, the mouse cursor using the hand, using the finger. So you can see that turn on the YouTube, then you can see that the way he moved the hand, so they will see the cursor is also moving. Then he will bend the finger to click, bend again, so then he will click. Yeah. Okay, so these are some of the works done by the students. It's actually not difficult. The libraries are available in the Google, so you just need to pull out and then actually try your own data set of it and then do some testing using the library. Okay? It's not difficult. I think it's still okay.
Can you show me the first one where I want to take a picture of the first one? Yes, this one.
But this grammar, I'm not going to ask you to buy and stop using this predictor. I mean, just educational purpose. You study first. You're going to buy using this. Okay? So that's all for today's lessons. Any questions regarding to your maybe assignment or maybe to the chapter 3 on informed search? You try the question first. If you still don't know, you come back to me. How to expand the notes, right? What is open, what is closed, you still don't know, then you come back to me. Then maybe if you've got time next week, then I will show you again. Alright? So if no more questions, then we will dismiss. We should have a happy holiday for Muslim. Any Muslim here?